So welcome to our webcast. This is the second one on the series of Informix Best Practices. Last month I did one on getting started with Informix, and next month I'll do one on disk space. I am Lester Knudsen, and I've been working with Informix since 1983, and developing very large databases, training, do a lot of training. I used to train for Informix back in the 90s, and then I do my own training. Anyway, and I have the privilege of working with a great group of guys here at Advanced Data Tools focused on developing systems. So I have a lot to cover today. In fact, I think as I was working on this presentation, I may break it into two presentations. I want to spend most of the time talking about CPU and memory recommendations and best practices. Then there's a whole bunch of other ONCONFIG settings that I may go over later. We'll see how we do on time. I'll touch on them if we have time. If not, I may just skip and make that a later WebEx seminar. So let's just dive in and let's start talking about CPUs. CPUs are the heart of our computers. They get the work done. And I want to talk about how to take advantage of your CPUs for Informix. So a couple of terms we need to understand here. And this has changed over the years. The first term is socket, and socket is a chip. It's the physical chip that you put in a computer. Now, many computers, in fact, most computers will have more than one physical chip or more than one socket. Then each chip can run multiple cores, and each core, hang on, I'm getting some echo here. I'm just going to make sure everybody's on mute. Each core can run one process at a time, and that's the key thing to understand. The core is actually what does the work, and if you have 8 cores, you can run 8 things at one time. Then, to confuse things, all the chip vendors have added some kind of hyper-threading, or in AIX it's called SMT threads, where a core can have multiple threads. Now, that doesn't really mean that a core is 2 cores. It means it can have a virtual core, and the way it works is every chip, every core has idle time. And so by having a virtual processor on that core, it takes use of that idle time for the second core. And the operating system will oftentimes see it as 2 cores instead of 1. But remember, it's really a single core with 2 virtual cores running. And I think that's a key thing. A virtual core is not real. It can't do 2 things at the same time. It can only do 1 thing at a time. But because the cores are so fast nowadays, oftentimes you think you've got 2 cores there, and it gives the appearance of having 2 cores. In many operating systems, you have to turn that on. And you can control how many threads you run on a core. Sometimes it's on by default. A lot of the Linux systems I install, the virtual threads are seen as a core. Let me give you an example here. And let's take a look at one of my systems. This is a system called Apollo. You notice it says it has 8 CPUs, and but it has 2 threads per core and it has 4 cores per socket. So it really only has 4 cores, but it can pretend like it has 8 by the ability to run virtual CPUs. So Linux, in this case, thinks that it's 8 cores. In reality, it's only 4. And that's what you've got to be careful about in planning these things. This is another system, and this system has 1 socket. It has 4 cores on that socket, but it only has 1 thread, so it has no virtual cores. And so it only is seen as 4 CPUs. And the reason is this gets very important when you're planning how many Informix processes to run, is to understand whether they're real cores or virtual cores or hyperthreads or SMTP threads. Then you have chip speed, and that's usually measured in megahertz or gigahertz. And that is, there's a race on to see how fast they can continue to process. And then just to mention, IBM has something called processor value units, which they use for licensing, and I'm not even going to touch about that. Configuring Informix has nothing to do with that. Processor value units usually tells you how good your chip is compared to a baseline of other chips, but it's not a hard and fast rule for that. So here's an example. These green boxes are 2 sockets, and each socket has 5 cores. So we have 10 cores. Now each core has 2 hyperthreads. So we have 20 virtual cores, but still only 10 things can run on a core. A core has to wait or stop to run something else on it. And so it goes back and forth between these 2 virtual cores. Now, the advantage of virtual cores is the operating system, because it thinks there are 2 cores there. Its queue can have something ready to run. So when the core finishes 1 virtual thread, it has something ready from the operating system to run on the other virtual thread. And this is very good for lightweight applications that have a lot of little processes. Websites, client servers, where you have thousands of processes running. This is really good. Where it's not that good is for something like Informix, which is a big process. And remember, the Informix on-init process is multi-threaded, so each on-init could have 1,000 threads running within it. And to have the on-inits continually swap in and out is not as efficient as having an on-init dedicated to a core and running all the time. So what are the best practices? Well, first thing you need to do is decide how many cores are going to be allotted for Informix. Is this a development machine, a test machine, or a production machine? And decide what else is running on the machine. The traditional best practice going back was you want to have the number of physical CPU cores -1, and that's how many on-inits of the CPU class you would want to run. So in this example, you'd say, okay, we have 10 physical cores, therefore we could run 9 on-init CPU class. That's the traditional. Now, today, cores are fast enough that each on-init, each core can handle 2 to 3 on-inits per core, or one rule of thumb that Art Kegel uses that I really like is about 1 on-init per 500 to 1,000 megahertz of power. So to come back here to my example, let's take a look at this one. I have 4 cores, but my cores are very fast in terms of megahertz. So I could easily run 3 to 4 on-a-net CPUs on these 4 cores. Now, that's on the physical cores, not on the logical cores. So let's say I decided to run 3 per physical core. That would be 3 times 4. That would be 12. Or if I was going to do it on the logical core, I'd probably divide that in half. Now, how do you tell how busy your CPUs are? There are things like SAR, VMstat, MPstat, TOP. They all tell you how busy your CPUs are. And we can take a look here. If I just run SAR, it gives me a report, and you can see it tells me by time. My CPUs are 99% idle. That's because this is a training machine and it hasn't been doing much all day. What you want to do is look at that idle time because everything that is not idle is busy time. And my rule of thumb is to plan for your average busy time to be less than 30%. So that you can save 60% of your CPU usage to handle workload spikes. And all of us, just like our day, we have spikes during the day when our work goes up and down. And if you're at 60% all day and then suddenly you have a workload spike, everything is going to slow down really bad. One of my favorite stories on this is I was at a bank helping them with a performance tuning exercise. I'd spent a week out there. We planned everything out, had a really good week, gotten some good performance improvements. It was Friday, the last day of the month. We went to lunch, and suddenly all the DBAs pagers started going off. Lunchtime, last day of the month, people started hitting the ATMs. People started hitting the bank. They had a spike. And that's what you need to plan for, are those spikes in your workload. If you're a retailer, Christmas is what you need to plan to handle. If you're a student registration system, registration period is what you need to plan to handle. The rest of the time, the system, the database may seem to be relatively idle. That's okay. You're planning to handle the spikes. And in CPU usage, that's what you want to plan for. Now, let's talk about hyperthreading a little bit. This is a good example of MPstat on a system that has 256 logical CPUs. And what you can see is the first one is at the actual physical CPU, that's 0 here, and then the 1, 2, and 3 are the logical CPUs riding on 0. The first one is what's busy. This is from an Informix production instance, and this is AIX. And typically, that's what you'll see is on a hyper-threaded or an SMTP system, the main core is going to be busy, and the virtual core, if you're running Informix on that box and it's totally dedicated to Informix, the virtual core may not be busy at all because the on-a-net process is going to attach to that physical core and just keep it busy. So the rest will appear to be fairly idle. So, SMTP threads, do you turn them on and use them or not? And again, it's really the best practice is to test. Don't assume that more hyperthreads or SMT threads are better. Your workload's going to determine it. I had a client recently I was helping performance tune, and they had bought a box with 48 cores, but each core had 2 hyperthreads. It was an Intel box, so they thought they were getting 96 cores, and that's what they wanted to run, was 96 cores. And we did some testing on that, and running it as 48 cores in the operating system, saying turn off the virtual hyperthreads, we could run 2 to 3 on-inits per core and got great performance. Turned on hyperthreading, same number of on-inits. Now we had the overhead of hyperthreading to deal with. And my rule of thumb was that was about 5% that they used up in hyperthreading. Now that box was big enough for what they needed, so it worked fine. But I would test. Don't assume that hyperthreading or SMTP threads are going to be better in your workload, because remember, they're virtual cores. They're not real cores, and they're still sharing that one core. And if you run 2 on-inits on the one physical core, you don't, without hyperthreading, you don't have the overhead of hyperthreading. If you turn on hyperthreading, then you get 2 cores there, and you still run 2 on-inits. You've got some overhead there. That's the thing to keep in mind. On AIX, I was talking to Art about this last night, going over the slides, and he reminded me that if you're on power 6 or 7, try 2 SMT threads per core. If you're on power 8, power 8 by default has 8 SMTP cores, threads per core. If you cut that in half to 2, that might work better. So my basic rule of thumb is you're better off running 2 on-init of the CPU class per core instead of turning on hyperthreading and running 1 per thread. But again, test. And that's the way you can really determine what works best for you. Now, Informix, let's talk about the particular on-inits that Informix has. Informix has a bunch of on-inits. Each on-init has a special job. Some on-inits do disk I/O, some on-inits handle connections. They all use the shared memory. That's how they communicate with each other. When you do a PS-EF and look at the on-inits, you'll see a bunch of on-inits running. Let's just take a look at one of my systems here. PS-EF, grep, on-init, and I've got a bunch of on-inits here running. What you want to do is run onstat-g sch to tell what those on-inits are and what they're doing. So if I come back here and do an onstat-g sch, I can see I have 13 on-inits, and the class tells me what they're doing. I have 4 CPU class on-inits, and those are the ones that you want to have based on the number of CPUs you have. So here's a list of all the on-init classes. Let's talk about how they get started and how you control them. Some get started automatically. PIO, LIO, FIO, admin, and miscellaneous. Those are going to get started automatically when you start Informix. There'll be one of them. You don't need to worry about them. There's no special tuning you have to do. If you run auditing, there'll be an ADT on-init running. If you have Java or user-defined functions, that will start additional on-inits that are for Java or your user-defined functions. The two that you control in the ONCONFIG are the VP class for CPU and AIO, and the net type class. So let's talk about these two. The CPU on init is the one that does the real work. That is these on inits right here that are CPU class. I've got 4 of them. Remember, I have 4 CPUs on this box. This is the box that had 4 physical cores. 1 CPU, 4 cores. And they do all the real work. They are processes. If you run top, they should show up on top of all the processes. And you control them in your ONCONFIG file with the VP class setting. The AIO on init handles disk IO. And I've got 2. Excuse me, I have 3. 1, 2, 3 AIO on inits. And we'll talk about that in just a minute, but they handle your disk IO when you don't have kernel AIO turned on. So the VP class parameter in your ONCONFIG is the key. That's how you control how you use CPUs. And the syntax is basically class name and then options. And I'm going to go through the options here. Basically, you say for CPU, you use the keyword CPU, and then number equal the number you want to run. And then this is really good if you have physical cores, not virtual cores. You want to affinitize them to particular CPUs. You can also say max, and that's the max number I'm going to run. Now, affinitize means run this on init process only on this core. Now, if you have virtual cores, that ain't going to work too well. I tend to avoid affinitizing on virtual cores, but on physical cores, they work great. And so here's some examples. The first example, I have an 8-core machine, and this is 8 physical cores, not virtual cores. I could say I'm going to run 4 and leave it at that, and that would leave 4 cores free for other things to run. Maybe I want to run another instance. Maybe I'm running Oracle on the same box. Maybe I'm running a web server. I could run 8, and that's going to run all 8. I could run 8 and say affinity equals 0, which means the first on init is going to affinitize to core 0, which is the first core, and it will be pinned to that core and only run on that core. And then all the others will be affinitized after that. Or I could say 8, and I want to affinitize 1 to 4, and I'm going to let the other 4 float. So they will go float on which core has the most free processing. So that's sort of the way you want to look at this. How many cores do you have? And the number should be the number. The old rule was number of cores minus 1. Now I think depending on the speed, you could have 2 or 3 per core. This is a fast machine. I could have 16 here and be perfectly fine with that. No age. I need to say something about that. Back in the old days when Unix started, it gave priority to interactive processes. And so something that was running over time got a lower priority. That was called processor aging. The no age parameter tells the operating system not to age your on init process. And so it won't get a lower priority. This is why a lot of people would reboot systems once a week, is because things that have been running a long time slowed down because the operating system lowered their priority. And then once a week, you'd reboot it, everything starts over again. With the no age parameter, you don't need to do that. I've had database servers that have been running up for 1,000 days. And the no age problem doesn't age that. So that's a key parameter to add to this. Here's an example of I turned on affinity to 4 CPUs. I set affinity 0 to 3. That means it's going to affinitize those to the processes. In your online log, you'll see something like this. If you don't see this, that means it was not able to affinitize them for some reason. So the CPU VP number 8 got tied to processor number 1. CPU VP number 9 got tied to processor number 2. CPU VP 10 got tied to processor number 3. And then CPU VP number 1 got tied to processor number 1. So, a couple of other best practices. In your ONCONFIG file, there is a parameter called multiprocessor. Set that to 1. Almost all machines today are multiprocessor. And I don't know why 0 is still the default. I wish that would be changed to 1. That basically tells Informix you're on a multiprocessor box, and will just make life a lot safer. It makes the code in the Informix kernel aware that you're on a multiprocessor box. Set the singles CPU VP to 0 will allow you to run more on-inits of CPU class. And you can dynamically add those on-inits as you go along. And the third thing is always turn on no age if your operating system supports it. If you remember the last web class, I showed you how to go look at the machine release notes, and that will tell you if your operating system supports it or not. Now, another key thing for Informix is the VP memory cache in KB. This is a parameter in your ONCONFIG, and you tell it how much memory to set aside for each core, for each on-init CPU VP class. So in this example back here, where I have 4, if I gave it a number here, as in my example here, each of those 4 will get 4,096 bytes of private cache. The advantage to this is that gives each on-init CPU process a private memory cache to use, and it doesn't have to go out to the main memory cache to get memory every time it needs it. It will use that private cache first, and then when the private cache is full, go out to the main cache. That gives it a bit of memory that it can use. And the default is 0. It's turned off. You can set it from 800 to 40% of shared memory total. No need to set it real big. I think 4096 is a really good number. I'll sometimes double it. Sometimes I'll make it half of that size. You just need a small amount. It depends really on how much memory you have total. But I'm a big advocate of using this parameter. And 4K is a small amount of memory for each CPU to have as a cache. You can also add the keyword dynamic or static. It defaults to static, but dynamic means it could grow if it needs to. And I'll talk more about some of the auto-tuning things later on, but that can be a good thing in some environments to set it to dynamic. Now, think about it though, when it grows, it's not going to give that memory back, it'll keep it. So if it has one job that needs a bunch of memory and it grows, it gets that, and then it doesn't give it back when that job is done. Now, let's talk about disk I/O. The default is auto AIO VPs are on, which means Informix will automatically add AIO VPs as needed. And for turnkey systems, for embedded systems where you don't have a DBA monitoring it, for development systems, for test systems, that's good. I like the auto stuff. For a race car, you notice race cars don't use automatic transmissions. Drivers use manual transmissions. And that's sort of the way I feel about these tuning parameters. For the optimal performance, you want to control the AIO VPs. And the reason is I've seen many cases where too many AIO VPs get started. And I was at one site years ago, and they had a performance problem, and I came out to look at it, and they had 256 AIO VPs. These are all processes, all trying to write to the same 4 disk at the same time. Imagine that, 256 processes trying to write to the same disk. They stumbled over each other very badly, and it slowed down the system. All we did was reduce that to a reasonable number, and I'll come to that in just a minute. So my recommendation is you turn off auto AIO VPs by setting it to 0, and you set the VP class AIO number, and then you give it a number based on how many on-inits do you want to write to your disk. Now, the rules I have for that are, again, test, test, test. I can't say that enough. But if you have KAIO on, you only need 2. KAIO will take care of everything else. This is kernel AIO, and this usually means you have to set something up in the kernel for that to happen. It also usually means you're using raw disk. If you're using cooked disk, KAIO is off, and it's going to depend on how many processes can write to a disk at the same time. That's the key question here. If you can have 4 processes write to the disk at the same time, then you want only 4 AIO VPs per disk. In my testing, about 8 is the most per disk. Now, in logical volumes, things we have, striped arrays, this gets very hard to measure. And the advantage of a SAN and an array is they hide the disk from you, and they speed up the access, and that's why I say test here. But you sort of can think about it as how many underlying disks. Get a ballpark number, 20, 30, 50, and that gives you an idea of the max number of AIO VPs. So the max number is going to be the number of disks times 8. Now, you really don't need any more than 2 per active chunk. So if you have 100 chunks, but only about 50 of them are active at one time, then you only need about 2 or 100 AIO VPs. Anything over that is going to be wasted. And so that's next best practice. Always plan out how you're going to use. Here are 2 examples. And you really see this when you have one disk. I've got one disk, 24 chunks. Even if all 24 are active, I would keep it down to 8 AIO VPs. unless it was on a SAN, but then I wouldn't have one disk. I'd have more disks. Now, if I have six disks, 24 chunks, but only 12 are active, then I would probably keep it to 12 active times 2 is 24. That would be the number I use for the number of AIO VPs to run. So what I'm trying to do is give you some formulas here that you can look at your system and tell what it is. So the basic formula here is the number of active chunks times 2 is the most you'll ever need of AIO, and I would even try with less than that. It's nothing is worse than the slowdown of 2 processes trying to write to the same chunk at the same time. And then at the most 8 per disk. So if you have a SAN and the SAN has 20 disks, you just say 8 per times 20, and that will be the most you want on AIO VPs. Now, the next kind of on-a-net we're going to deal with are the ones controlled by net type. And if I open up my onstat-g SCH, you can see here that I have one that's a socket, and that's controlled by the net type setting. And you have sockets, TLI if you're on Solaris, and shared memory for shared memory communications. So how do you determine how many on-a-nets to run for these? The rule here is you have a net type setting, you tell it the protocol, this number right here is how many on-a-nets to run. So if I put 4 here, I'm going to run 4 on-a-nets. If I put 1 here, I'm going to run 1 on-a-net. And then I have the number of connections per on-a-net. So it's 50 connections times 1 on-a-net. 250 connections times 4 on-a-nets. And then I have telling it what type of on-a-net, whether it's going to be a CPU on-a-net or a network. If it's a CPU on-a-net, it's going to use the CPU class. And so you won't see a separate line here for sockets. Now, I'll come to it in a minute. There's a disadvantage with running some on the CPU, particularly non-shared memory connections. So my basic rule of thumb is you want your shared memory connections to run on type CPU. That's what I have here. Shared memory connection, run it on type CPU. You want your network connections to run on type net. And the key reason for that is if you run network on type CPU and you get a network hang, your whole CPU hangs. You can have your whole system hang because of a network hang. So don't run your network connections on a CPU. You can run 200 to 300 connections per on-a-net process. So here are a couple of examples. I have one on-a-net for 50 users. Now, if one more user comes along, that's okay. It'll dynamically handle that. That's not a problem. So I'm setting it up for 50 shared memory connections. And then here I have 4 on-a-nets of 250 users each. I'm setting it up for 1,000 network connections. So that's my on-a-net recommendations for setting up on-a-nets in your ONCONFIG. And boy, looking at the time here, this is taking longer than I thought. So let's talk about memory. The second part of this, I think I'm going to skip the last part and we'll do that as a separate presentation. Memory recommendations and best practices for Informix. So first question is how much memory is available on your machine and what other applications are using it. And how much will be assigned to Informix. What you don't want to have happen is the machine to swap memory to disk. In past years, when we did the fastest DBA contest, the last time we did it, we ran it on a MacBook Pro server with 8 gigs of memory. And I told all the participants that, and I said, I would save at least 2 or maybe 3 gigs of memory for the operating system. So limit, this was my recommendation, is limit your memory to maybe 5 gigs that Informix uses. And sure enough, you know, several people tried very fancy ONCONFIGs with big buffers, because big buffers are going to speed things up. They don't speed things up when you run out of memory and you have to swap to disk. I had several times where people would go in and make the changes, make all these big buffers, and then the machine would boot up to a crawl when you started Informix because it was swapping out to disk. The key thing is if you just do an onstat minus, right here, you see how much memory Informix is using. And so this machine, I'm using 3.6 gigs. Now, I'm running on a 6 gig machine here. This is a little Linux server that we use for our training classes. And they have 6 gigs each, and I'm using 3.6 gigs of that. So that's sort of what you want to do. Now, if you have a lot else running, like if you're running another database or you're running a web server, then you probably want to reduce that. And so the first thing you want to do is decide, okay, I have 16 gigs of memory. I'll save half of that for the operating system and the web server, and then the other half for Informix. Or I have 16 gigs of memory. Informix is the only thing that's running on this. I'll save 4 gigs for the operating system, and everything else goes to Informix. That's what you have to decide first. Then, once you've decided how much memory to allocate for Informix, you need to allocate that by memory class. And Informix has 4 memory classes. They have a resident memory segment, a buffer pool segment, a virtual memory segment, and a message segment. The message segment, don't worry about. That's a small segment. It's basically a buffer for your users. It actually is controlled. There's a certain amount by how many connections you set up, and that's what gets set up there. It's usually small. What you need to worry about is the resident, the buffers, and the virtual memory, the other 3 segments there. And the command to look at this is onstat minus G SEG. So if I come over here and I say onstat minus G SEG, I see, okay, I've got a resident segment, that's the R in the class, I've got a virtual segment, I've got a buffer segment, and I have a message segment. And by the way, the asterisk means that I have pinned that to memory. It will not swap out, and I'll tell you about that in just a minute. Here I've got a resident segment, a virtual segment. I have 2 buffers because I have 2 different pages with buffers. And then I have a message segment, and then I have 2 more virtual segments. So the 4 ONCONFIG settings for controlling memory are buffer pool, shared memory virtual size, shared memory add, and locks. And I'll come to locks in a minute, but that's a key one in controlling memory. So buffers, let's talk about that. More buffers is better and faster. and your database will perform much better. The number one thing I do in performance tuning is look at buffers and can I increase the buffers. You want to put all of your active data into memory if possible. I had the privilege of working with a client that had a 96 gig database, and they had 256 gigs of memory. We made the buffers big enough that the whole database, as soon as a page was read, it was in memory, and it stayed in memory until the server was rebooted. That was great. You can't get better performance than that. But most of us don't have that much memory or that small a database. And so the goal is to prevent high memory buffer turnover. Art Kegel has a great rule of less than 8 times an hour. And that's what you want to look at, is how many times does your buffers turn over. And I'm going to show you a script to do that. Art has a couple of great scripts at his website. And I've got a SQL script. The last thing I want to mention is always leave the default line. If you view your ONCONFIG file, at the very end of it will be a default line. Always leave that default line there. I've actually had problems when I've seen people take it out. Informix needs defaults, and that's where it gets the default from. So, what can you do? The buffer pool line is basically made up of a size, which tells you the page size of that buffer pool. And that means that all DB spaces that are of that page size will use that buffer. That's why the default line is important, because if you don't have, let's say you have an 8K page size, and you don't have a buffer pool line that says size equal 8K, it will use the default. Buffers is how many 2K or 4K or 6K buffers will be created, how many LRUs, and I'll get to LRUs in a minute, and then the LRU min and max. This basically sets up your buffer pool. Now here's some examples. On a Linux machine that's OLTP, I have a buffer pool 2K. I'm using 3 gig of memories for buffers. And I set the LRUs to 32, and I have a min and max of 10 and 20. These are sort of quick examples from some of the systems I've worked with in the last year. AIX, I have a 12 gig memory buffer. Because it's 4K page size, I put here 3 million buffers times 4K equal 12 gigs. And it's a lot busier system, so I have more LRUs, and I have an LRU min and max of 1 and 2. On a data warehouse on Solaris, 2K page size, but I have a lot of buffers. I have 48 gigs of buffers and a lot of LRUs, but because it's a data warehouse and not OLTP, I have the LRU min and max at bigger numbers. And here's an example where I have 4K and 16K buffers. And I want 15 gigs of memory for the 4K and 12.8 gigs for the 16K. And I set up those 2 settings. So here's my script. And if you've been to any of my SysMaster talks, you've probably downloaded this script. It's called buff BTR ratio, and it tells you how many times per hour your buffers is turned over. The goal is less than 7 or less than 8 times per hour. And buffer turnover ratio is churn. It's swapping of your buffers, and you want the less swapping, the better. The best way to reduce it is to increase your buffers. And I was working with a client that had their buffers turning over 300 times an hour. That's, you know, what, 4 times a minute. Everything in memory was getting trashed. And over time, we worked at increasing their buffer pool, and that's all. The only change we made over time, increase their buffer pool. Well, we did some other changes, and their buffer turnover ratio came down to about 4 or 5, and that's what you want, 4 or 5 times per hour, and you get that by increasing your buffer pool size. Now, let's talk a bit more about LRUs and how Informix manages memory. When a select comes in, Informix reads a page from disk and puts it into a buffer. And the buffers are controlled by LRU queues. And when all the buffers are full, the LRU queues then wake up and discard pages to make room for more data, so you can keep going. Now, as long as those pages are read-only and have not been updated, that's fine to discard them. And the LRU queue's job, and it's called least recently used, is it looks at the buffer pages that have been least recently used and discards them and brings something in. Where you get churn is when you discard a page and then a minute or 2 later bring it back in, and then discard it and then bring it back in. That's churn. Now, this gets more complicated when you start doing updates, because now the LRU queues can't just discard pages, they have to write them out, make sure they're written out to disk. And it uses the LRU max dirty and the LRU min dirty ONCONFIG values to decide when to start writing data out to disk. LRU max says start, LRU min dirty is stop. So the default is 60 and 50. So that means when 60% of your buffers are dirty, it starts writing out to disk. And when 50% are dirty, it stops because it's done its job. LRU queues are great. They're background writes. They don't hurt anything. They're what I call they're lazy writes. Lazy is not the right word, but they're low impact writes. When they can't keep up, and this is what you want to avoid, is a foreground write. That's when all processing stops and it has to write a page out of the buffer to disk before it can continue. And the command to look at this is onstat -F, capital F. And this tells me on my little system here, I've had 4,756 foreground writes. That's not good. That means 4,756 times in the last day. I've only been up 1 day and 16 minutes. Everything has had to stop, and it has to do a foreground write. I've got this many LRU writes, and then chunk writes are checkpoint writes. That tells me how many checkpoint writes I've had. Now, LRU writes are friendly writes. They don't stop any processing. Foreground writes stop processing. Chunk writes don't always stop processing, especially in version 11.5 and greater. They're actually pretty good. Think of these as checkpoint writes. but they can have an impact on your performance. And so you want to avoid too many chunk writes, particularly in an OLTP system. And the way to look at that is do an onstat minus GCKP to look at your checkpoints. And this will tell you, let me make the screen a little bit smaller so you all can see it without it wrapping around. There. The block time tells you how much time was blocked. Now, you notice here I've got some big flush times, but I didn't have any block time. Because these checkpoint writes, these chunk writes, are intense, even though I didn't block anything, they probably caused a performance impact on the system. And that's what you want to avoid. And the best way to avoid that is to make sure you have a lot of LRU writes. I can tell you from my system right here, the fact that I had basically 3 times as many chunk writes as LRU writes, I don't have enough LRU writes. And I would look at making my LRU max dirty and LRU min dirty smaller to avoid that problem. So when a buffer is written to disk, it's marked as clean and it can be reused. When you have a checkpoint, it comes through and it writes all dirty buffers to disk, and this whole cycle starts over again. That's why checkpoints are so intensive write-wise. They don't block anymore. That's a version 7, 8, and 9 problem. In 11 and 12, they don't block, but they can write a lot of data. And I think it's the best practice to try and reduce the number of checkpoint writes and increase the number of buffer writes. Now, the one exception, there's always exceptions, is if you're doing data warehouse loads. Checkpoint writes are more efficient. So if you can afford them, they're the more efficient way to go. Now, some LRU tune settings. There's something called auto LRU tuning. 1 enables it or 2 disables it. If you have it enabled, there's nothing you can do in terms of setting it. It's going to automatically increase and decrease. And the auto tuning stuff is great for systems where you don't have a DBA monitoring, for turnkey systems, when you got to put something out in the field. We did a system for the Army that had a bunch of laptops that was going to be used by folks out in the field. They had no DBAs. They're not going to see a DBA for 6 months. Auto LRU tuning is what you want on something like that. Now, if you're building a race car, though, you want to fine-tune the LRUs, and you want to disable LRU tuning. And the questions are LRU, number of LRU queues you have, the LRU max dirty, that's when it starts cleaning, and the LRU min dirty, and that's when it stops cleaning. Now let's go over that. The number of LRU queues is basically how many queues do you want to divide the buffers up into. The more users you have, the more LRU queues you want. You know, if you're a 1,000 user system, you probably want more LRU queues because that allows more people to interact with buffers at the same time, since each queue is an independent thread. The less users you have, if you have a small data warehouse with 8 or 10 users, you don't need that many LRU queues that has a load process. But again, if you have 10,000 users, you want a lot of LRU queues. The max number of LRU queues you can have is 512, 512, and a good, 32, 64 is probably a good starting place on most systems. So the best practices for tuning memory, one is enable auto LRU tuning for embedded systems. Disable it for high performance systems where you don't want checkpoint writes to cause a huge amount of data to write to disk and slow everything down. And that's a repeat of that slide. Now, the last part of this, well, there's actually a couple more things. I'm already going over and I'm only halfway through. But we'll finish the memory and then break, and I'll do the rest in the next webcast. Is shared memory virtual size. This controls the size of the workspace, and it needs to be large enough so it doesn't grow, and you can monitor it with onstat-g SEG. Here's an example. Onstat-g SEG, I've got 2 segments that have been added. And what that means, when virtual memory needs to be added, the on-init has to stop everything. And this is interesting when you look at the microprocess. And it goes to the operating system and says, I need more memory. And the operating system has to go out there and say, where can I get more memory for this on-init process? And it comes back and says, here's some more memory. And then if it stops again, runs out of virtual memory, it goes back to the operating system. That can be an expensive process. On some chips and some operating systems, more expensive than the others, but in any case, it's going to be expensive. And you want to avoid that. So the best practice is to monitor with onstat-g SEG how much you need in terms of virtual segments, add it all together. So I would take this number and these 2 numbers, add them together, and that's what I would set my virtual segment size to. Now, a couple of last things on memory. Resident controls whether the memory is resident. That means it will not be swapped. Now, this depends on your operating system, but most Linuxes allow you to lock memory in. You remember back here, I showed you the command, and I said there are 2 asterisks here. These asterisks tell me that these are locked in memory because I set the resident flag. So off is a default. 1 will lock the resident segment into memory. N will lock the next number of segments, and -1 will lock everything in memory. Now, because it cannot be swapped out, you have to have enough physical memory for it. And other things may swap out. So Informix may run fine, but your web server may suddenly slow down. So you need to be careful with this and make sure your system is not swapping. Now, locks. I want to talk about locks because when I was doing some original benchmarking, locks turned up to be the 3rd or 4th thing in terms of performance improvements I could do on benchmarking. And that's because Informix starts up with a lock table. Every time you open a database, you add a row to the lock table. This is a table in memory. Every time you read a row, you read an index. So reading a row with 5 indexes might place 5 locks in the lock table. When that lock table in memory becomes full, it can dynamically be added to as needed. However, that adding to it can cause a performance problem. In fact, it's one of the reasons I've seen the virtual segment increase is, oops, I need to make the lock table bigger, and there's no memory, so go out and get me some more virtual memory so I can make the lock table bigger. It's sort of the way Informix works. looking at the last line of onstat minus K is how you tell if you need to increase your locks. And in this example, I've had 2 lock table overflows, and so the system needs 80,000 locks in total. Doesn't need them right now. There are only 5 active right now, but it has used 80,000, and that's why I've overflowed the lock table twice. So key parameter, set your locks to whatever is the total here in onstat minus K. Now, I think I've run out of time. I'm going to save the rest of this for a later webcast that we'll do on the rest of the ONCONFIG. Let's just go through to the ending here. And I've got a couple of announcements, then I'm going to take questions, and then we'll see what happens next. So next webcast is March 30th. It's going to be on disk and DB space. Maybe what I'll do is after that, do the rest of the ONCONFIG and then do the backup and recovery one in May. But this is a series, I'm having a lot of fun doing these, by the way, just best practices that we do. I want to highly recommend, if you're able to go to the IIUG conference in April. It's April 23rd to the 27th. Does it work if I click on that? Yeah, it does. Last time it didn't work. This is the 3 days largest gathering of Informix users in the world. And I'll be there, and our whole team from Advanced Data Tools will be there. We'll all be doing presentations. So come enjoy the fun, good food. And if you're not a member, I would recommend you join the IIUG. Membership is free, and it gets you a $100 discount to the conference. Just a couple of other things I want to recommend. One is this roadshow by Carlton Doe. Carlton's doing a series of roadshows on version 12, and we're at 23rd. So he's in San Francisco right now. It's 2 days. One is a roadshow and one is an Internet of Things project. Next week he's in Dallas. He'll be in New York, Atlanta, and he's coming here to Washington, D.C. in April. Looking forward to that. Highly recommend that if you want to know the latest of what's going on in Informix. And the last thing is we do a lot of training. I actually have, I'm really looking forward to this, in April, a private course for a group in Malaysia. So I'll be doing it in Malaysian time, which means I'll be starting the class at about 6 p.m. my time, and I'll stay up all night. It'll be the regular daytime, but we do private classes. We guarantee to never cancel a class as long as one student is registered. Now, if you don't register and try and do it at the last minute, we may be full. That's happened. But our schedule right now, we have a class coming up in April for new DBAs. That should be a lot of fun. So I'm going to open it up to questions. And what you want to do is pull up the chat window and send a text message to everybody so I can see it if you have any questions. If I don't get them answered or you have a question later, please send me an email, lester@advanceddatatools.com. I do travel a bit. I'm going to South America next month, so I'll be gone for 2 weeks. And so when I'm on travel, I don't always get internet. But so if I don't respond right away, I apologize. It just means I'm busy, but I'll try and get back as soon as I can. And one question that always gets asked, so I'm going to answer it right now, is the slides, and we are recording this webcast. They'll all be up in about 2 days on our website. So if you go to our website, let me make sure this works. Webcast replays, you can see this is the last one I did in January, and the slides are right there for you to download. And I'll have this one up in about 2 days. So any questions? Wow, no questions. I am impressed. Well, I'm going to end the webcast, and if you have any questions, please send me a follow-up email. I appreciate everybody coming to these things. They're a lot of fun to do. I like, it's funny, most of our team here, Mike and Tom and I, and Art, we all like sharing what we've learned from Informix over the years. It's been such a great product. And we appreciate you all taking the time to come attend our webcast. So we'll see you next month. Have a good day, everybody. Bye now.